Welcome to the show. R-2000, the better built house. Looks like we're attaining new heights here. In the past few shows, we've been looking at how to improve the air tightness in a house and how to upgrade its insulation values. In this program, we're going to look at the doors and the windows of the energy-efficient house. How to buy them, install them, that sort of thing. The co-host of the show, Oliver Drerup, is an experienced builder of energy-efficient houses. And he's making his grand entrance through the mud right now. Hi, Oliver. Nice entrance.
Don't you go anywhere now.
Window openings are pretty creepy without windows in them. How do doors and windows fit into the sort of energy scheme of the energy-efficient house?
Well, what's interesting about them is that they really don't occupy that much of the exterior surface area of the average building, maybe 5%. But they can represent as much as 20% of the heat loss from the building.
Is that true of doors as well?
Well, in the case of doors, there's less surface area, and they tend to be better insulated, but it's still a concern. We've already discussed the placement and orientation of windows. I think what we need is a quick review.
Substantial energy contribution can be made to a house through placement of windows on the south face. However, in the better built house, it is necessary to limit the amount of south-facing glazing to 6 to 9% of the interior floor area of the house in order to avoid overheating. Windows should also be protected from the direct summer sun using overhangs, awnings, or by clever placement of deciduous shade trees.
So now that you've left all these openings in the structure according to those guidelines, what about the actual windows that go in the openings?
Well, that's the next step. Why don't we go over to a window supplier and take a look at some of the options?
There are an awful lot of different kinds of windows. How do you decide which ones to use?
Well, what we're looking for is a window that has a good R value, good insulating value, that doesn't have a very great deal of air leakage, that's as inexpensive as we can possibly obtain given our market requirements, and that's aesthetically pleasing to our client.
That's a mouthful. I guess we better break it down a little bit. What windows have the best insulating value?
Well, to start with, you have to look at the number of pieces of glass in the window and the air films, or the air spaces between them.
So the more layers of glass, the better insulation?
Actually, it's not the glass that insulates. It's the still air films that create an insulating effect. A triple glazed window is usually better at insulating than a double or a single one because of the extra still air layers. But it's not only the number, it's also the size of the airspace. Too small an airspace and the insulation factor isn't there. Too large and convective air movement will decrease its effectiveness.
This is a pretty neat model of a double glazed window. I've never seen how that works before.
Yeah, and this is triple. What's really important here is the optimization of the airspace between the glazings. It optimizes around 1/2 inch. You want to make sure that it's not less than that or you don't get the thermal performance, and much more than 3/4 of an inch and it begins to convect like crazy in there.
Just like a hollow wall. You know, they keep the windows so clean in here. How do you tell what you're looking at?
I got a neat trick for you. What you do is you use a match or a lighter and you count the number of reflections that you see.
That is a very neat trick.
Now that works really well unless you're looking at a glass that has a film on it, like this example of a low E. This is just a single pane of glass, but on top of it, there is a coating that's been deposited there which has significant implications to the way in which the glass performs in a window. It actually reflects heat back into the building and does a very much nicer job than a standard piece of glass.
What are the kind of relative R values for all of this?
Well, if you have 2 pieces of the low E, you really have a window that will perform pretty close to the same R value as a triple glazed normal glass window.
But let me guess, with all these choices, the low E probably costs more. You have to make a decision based on that.
You always are looking to get the best bang for your buck. It's really important to try and make the thing as cost-effective as possible.
I bet you use the R-2000 program.
You do. That's exactly the way you can go about modeling the performance of windows and whether they should be double or triple glazed.
Now, what about styles? This is a conventional casement window, as far as I can see.
That's exactly what it is. But the thing to point out here is that there's a crack that runs all the way around the window. And of course, because it's double hung, there's another crack that runs across the center. As a result, there's more crack in this window than there are in some other styles of windows. Take a look at this one here. This is exactly the same window we were just looking at, but lying on its side. And then lastly, if you look at a casement window, you have a window that actually doesn't have a crack in the middle, but closes directly down on top of its seal.
That seal also looks like it's an awful lot better than some of the other seals on windows. That must be important. I mean, we make the whole building airtight, right?
Well, one of the things that I'm about to do is go down to ORF and look at how they test windows for air leakage.
That's right, your little secret trip to the ORF without me. You going to tell me all about it when you get back?
You bet I will. I'm here at the Ontario Research Foundation talking with David Bailey. He's the technical manager of the Building Performance Center, and he's going to be telling us about how they test windows. And David, that is my first question. How do you test a window?
Well, Oliver, when a window arrives, we mount it into this test chamber, and we carefully seal it into the opening. The equipment then simulates a wind of about 25 miles per hour, and our calibration equipment here records the amount of air that's leaking through this window.
So how does a builder find out about the results of these tests you're doing?
Well, they're usually published in the manufacturer's technical literature, and what we find is that they put out a statement about the quantity of air that's leaking through the window frame, and it's stated in cubic feet per minute per lineal foot of window opening.
Well, David, is there some kind of standard against which all these windows are compared?
There is a standard that we test to, and it involves a review and a testing directed to the air leakage characteristics, the water penetration, wind loading, and structural and operational characteristics of the units.
Well, what kinds of things are you testing for? I mean, what are you looking at?
Well, there's a couple of things that we look for. First, the quality and the compatibility of the weather stripping and how it relates to the motion of the window. We find that a cheap or a flimsy weather stripping that doesn't relate properly to the operation of the window just won't stand up in time.
So you're actually selecting the weather strip depending on the type of operation?
That's correct. The weather stripping is chosen as it relates to the type of window operation. This type of weather stripping, a neoprene gasket, works very well under compression. We also find that the operation of the window has a great deal to do with the air tightness of a window unit. As we all know, sealed window units, fixed windows, have the best air tightness characteristics, but most of us like to open windows. So the next best tends to be a window that compresses the weather stripping, and that would be a casement or an awning unit. These are somewhat tighter in general than a sliding horizontal or vertical window, although most of the units these days, the sliding units, are up to a good quality as well. We also find that it's very important that the latch securely fastens the window snugly against the weather stripping so that it's effective. Hey, Oliver, I'd like to ask you a question. How is it that builders select a window for their projects?
Well, in the field, it's generally cost, and more cost. But there are a couple of other issues that people are looking for. Our clients are very concerned about maintainability, and we have to judge the aesthetic nature of the product and how well it's going to fit into the project that we're building.
Well, I think, Oliver, if they use their normal criteria for selecting a window, and they combine that with the data that's produced from the technical testing, I think they'll be in an excellent position to do their window shopping.
So could you just summarize for us the points that everybody should be looking for?
Related to air tightness, it's primarily the weather stripping and its compatibility. It's the overall motion and operation of the window and the closing mechanism.
Well, I've really enjoyed having the opportunity to go through this facility. It's a very impressive laboratory, and thank you very, very much.
Well, we were pleased to show you the facility.
David, what are you doing?
But Oliver, these windows don't fit in these window openings.
No, you're right. That window doesn't fit in that window opening, but this one does. Come in here and take a look.
Ah, they would fit in this window opening.
This window fits perfectly. What I want to show you here is the poly wrap that's been done on the window. This poly has been adhered to the window by first laying a bead of caulking on the window, then laying a strip of poly on the window, stapling it through just to hold it, taking little tucks in the corners, and then wrapping the whole thing with glass fiber tape and stapling through the tape, the poly, the caulking, and the window. What that gives us then is a piece of air vapor barrier which is actually attached to the window. And notice what happens to the tucks in the corners when they then get laid back against the wall. By laying a bead of caulking in here, we're now able to get a complete seal. Prior to doing that, though, the carpenters or insulators are going to come in to any gap left between the window and the rough frame and insulate it, seal it with this, and you got a tight job.
I have a feeling there's a little saying in here that if you're buying an airtight window assembly, you install it airtight as well. Huh?
You got it. And in fact, many manufacturers make very good window units, but when they join them together, they don't always join them airtight. So where you see this joint, you'd be very well advised when you put your interior finish on to just run a bead of caulking behind it to make sure you've got a good seal.
You should go into the helpful hints business with things like that. It reminds me, I could probably wrap those windows, you know, because I went to summer camp. We had to do our bed like that every morning.
Yeah, Nurse Brown. There's another way around that. You can use a plywood wrap, as we have on this window. The plywood in this case has been nailed through a bead of caulking and bedded directly onto the window without breaking the glass. What you then do is seal or foam, using something like one-component polyurethane, the joint between the plywood and the rough frame. Alternatively, if you're looking at a double stud wall, you might take the plywood and adhere it first to the frame, and then the foam would be in this joint between the window and the plywood box.
If that gap were small enough, could you just caulk it instead of use the foam?
You could. You're really relying on the plywood here as your air and vapor barrier, because plywood is. What you wind up doing then is finishing the entire opening with drywall, top and sides, and whatever sill your client wants. It's usually the least expensive way to go.
Great, so you can make the window totally snug and everything. Now, I guess the best thing to do with the front door is to caulk it shut and tell the people to crawl in through one of the windows, is it?
Well, that'd be nice. It's difficult to do that, though, because clients like to live in these houses. Let's go look at some doors.
Okay.
So, David, you can see here that we've got exactly the same kind of poly wrap around the doors as we had around the windows.
So you treat the installation of this unit the same way you treat the installation of a window. But I guess you don't have to worry about passive solar gain through a solid door, do you?
You don't have to worry about it through a solid door, no. But you've got to remember that patio sliders, sliding glass doors, can introduce a large square footage of glazing to your home, so you should be very careful in how they're oriented, and you really should buy them as though you were buying a very high-quality window.
Okay. Well, there must be a trade-off then. If you don't get any passive solar through a door, you can probably, going from the fact that you don't have to see through it, get a better R value. What's the current state of the art?
You can get a better R value. What we've got here is a steel door. There's a steel plate on either side with an isocyanurate foam that's been put inside for a core. That isocyanurate will give you, say, R-12 as compared to R-3 for a wood door.
What's the steel for? Is that fire safety?
It's partly for fire safety, yeah. But it's also there because it enables you, for example, to use a magnetic closer on the door. We've got weather stripping here that will actually jump right onto the surface of the door when it's closed and seal it all the way around.
Well, it sounds like a good seal, so you don't sit near the front door and feel all those drafts coming through.
No, you sure don't. You also have to be very careful about sealing it at the bottom as well. But you should give some thought to the orientation of the door. You don't want it facing the prevailing winds, for example, in a little alcove like this. Where'd you go?
Well, I guess, as with everything, a little pre-planning really helps, you know, orienting the door opening, for instance. And also, since you have such a beautiful wall assembly where you're sealing around every little pipe, it makes a little bit of sense to pay attention to these great big openings you're punching in it.
Sure does. Recognizing that windows and doors represent perhaps 5% of the exterior surface area of the building, they can account for as much as 20% of the heat loss.
Right, and as I learned at the window store, you buy really good windows and doors.
You sure do, and as we also learned from the Ontario Research Foundation, those windows and doors are tested for infiltration rate. So you buy partly by cost, partly by aesthetic, but also based on that infiltration rate.
So, what's in store for the next program?
Well, we've looked at the assemblies for foundations. We've looked at the assemblies for walls, windows, and doors. So it seems reasonable that the next thing we're going to look at are going to be roofs. We're going to look at vapor barriers, how to make them airtight, how to deal with penetrations, how to insulate them. Same issues we've been looking at all along, but in roofs.
So we'll be down on the ground looking way up at the roof next program.
No, we're going to be on the roof.
You're going to be on the roof shouting down at me in the next program?
No, David, I thought we'd both go on the roof.
Well, we can see what happens, but I'll bet you a quarter that I don't make it to the roof.
That's my quarter.
Hey, come on back for the next program and join us on R-2000, the Better Built House, and find out whose quarter it is.